Welcome to Chem Help ASAP. In this video, we'll see how reaction order can help one determine the mechanism of a reaction. At the top of the screen, we have a substitution reaction. You have two friends who ran this reaction in lab and are debating whether the reaction follows an SN1 or an SN2 pathway. Since your friends cannot agree, they ask you to break the tie. The winner gets a free dinner from the loser. This is important. The two possible mechanisms are on the bottom part of the screen. If it's an SN1, the chloride could leave to make a secondary carbocation. You then attack with the iodide and make the product. Secondary carbocations are not great, but at least they're better than primary. In the SN2, the iodide just attacks and displaces the chloride. Iodide is not one of the typical great nucleophiles, but iodide is certainly a large polarizable ion to help with nucleophilicity. You have a hard time deciding on a mechanism, and then remember watching some videos about reaction kinetics. It should be possible to determine which mechanism is operating through experimentation. You tell your friends to set up the reaction 2 more times, side by side, and monitor the progress of the reaction. One reaction should have twice as much sodium iodide as the other. Your friends repeat the reactions and report that the reaction with double the sodium iodide took about half the time as the other. You tell your friends that the reaction most likely goes through an SN2 mechanism. Like a detective on a TV show, you explain that the rate equation for the SN1 reaction is first order and does not depend on the concentration of the nucleophile, iodide. The rate equation for the SN2 mechanism, however, is second order and does depend on the nucleophile concentration. Because the rate of this reaction depends on the nucleophile concentration, it is most likely an SN2. Your friends are completely impressed and buy you dinner. This reaction, the substitution of a chloride with an iodide through an SN2 reaction, is actually a known reaction. It's called the Finkelstein reaction. Questions involving reaction order are very common on standardized tests like the GRE and the ACS exams. The question will show a reaction and ask how the rate will change if a reagent concentration is doubled or altered in some way. Answering these questions requires you to know both the rate determining step in the mechanism and the role of each reagent in that step.